Hello children, let's understand the covalent bond formed by carbon. So, I'm sure it is really interesting to know that carbon does not lose electron or gain electron, rather it believes in sharing. Yes, carbon shares electrons. How it shares electrons? Let's understand in detail. So, what is covalent bond? A chemical bond which is formed between two atoms, and these two atoms are mainly non-metals. So, there is bond formation between non-metals by mutual sharing of valence electrons between these two atoms. So, what happens is, what is the important key term in the definition? There is a mutual sharing of electron. Think about ionic bond. Was there sharing? No. There were transfer of electrons taking place between a metal and a non-metal, right? While what happens here in the covalent bond? There is sharing of electron. Why? Why carbon wants to share? Why should not it transfer electron? Because it cannot do so. As you know that carbon cannot lose electron or gain 4 electrons. So, it participates in sharing electrons and stable its configuration. So, what happens here? Covalent bond is formed between two non-metals by sharing of electrons between those two non-metals. So, let's think about the example. So, it's not necessary that it should be carbon only which actually shares like this. As I said, all the non-metals, they can do sharing. So, can I say non-metal when bonds with the other non-metal? Which type of bond is formed? When a non-metal and non-metal combine or share electron, they lead to the formation of covalent bond, right? And what about ionic bond? When a metal and a non-metal, they combine by a bond, that is ionic bonds, which exist because of transfer of electron between them. But here, covalent bond exists between two non-metals by sharing of electrons. Yes. Let's understand some examples. So, to understand the examples, let's also talk simultaneously about the types of covalent bond. So, children, there are 3 possible types of covalent bond that can exist: single covalent bond, double covalent bond and triple covalent bond. So, let's understand one by one with various examples. In that ways only we will be able to understand how sharing takes place. So, what about single covalent bond? Think about the meaning. What is single? Single means one, right? So, here the covalent bond will be formed by one electron shared by each atom. How? Let's do the example first and then write the definition accordingly. So, when we talk about hydrogen, how is covalent bond formed? Between two non-metals. Is hydrogen a non-metal? Yes, hydrogen is a non-metal. So, there are two hydrogens. So, two non-metals are there which can share their electron. How? Think about the electronic configuration of hydrogen. It has atomic number 1. So, it has one valence electron. How many electrons this hydrogen needs to become stable to complete its first shell? In the first shell, it should have 2 electrons. So, it means it needs one more electron, right? So, this hydrogen has 1 electron. I am showing its electron dot structure. So, I have another hydrogen, it has 1 electron. They both are sad, they want to become stable. So, how will they become stable? They share their electrons with each other. Yes, think about this. If this hydrogen share this electron, it will have 2 electrons in the shell. Similarly, this hydrogen will share the electron from the other. In this way, they both are happy because they both have achieved stable configuration. And how many electrons are they sharing with each other? It is sharing of 1 pair of electron. What is I am saying? 1 pair of electron. 2 electrons is 1 pair. Or in other words, I can say 1 electron is shared by the one atom and 1 electron is shared by the another atom. So, each atom is sharing 1 electron. So, what is this? This is single covalent bond. Why it is formed? When there is a sharing of 1 pair of electron. Can I write the definition now? Yes, it is the covalent bond formed by sharing of one pair of electrons. Yes, so it is mutual sharing of one pair of electrons. Why do they want to share? Because if they are not losing electron, because why hydrogen will lose electron? Because there is no other atom which can gain that electron. So there is no possibility of transfer of electron. They both are non-metals. They cannot lose or gain. So the better idea is to share electrons. And how will they share electrons? As you can clearly see that each hydrogen atom needs one more electron. So they share electron in order to become stable. So let's take another example. So this is how we draw electron dot structure of covalent bond. Now when we talk about fluorine, F2, I'm sure you know that fluorine exists as F2 molecule. So the question arises, how F2 exists? The atomic number of fluorine is 9. So it is 2, 7. So it has 7 valence electrons. How many electrons fluorine needs? Think about it. So as you can see, fluorine has 7 electrons. It needs one more only, right? But there is no metal who can transfer that electron. So what will happen? So as we know that one fluorine has 7 electrons. So I am drawing the electron dot structure of first fluorine. Then I have another fluorine because F2 means there are 2 fluorine atoms. So it needs one more electron which will be shared by another fluorine, and similarly this second fluorine needs one more electron which will be shared by the first fluorine. Are they stable now? Yes, they both have complete octet. So they have got stable noble gas configuration. So how many electrons are shared by each? One electron each, right? So there is single covalent bond formed between these 2 electrons here as I am showing. So now when we have drawn F2, is it a single bond example? Yes, because they have shared just one pair of electron with each other. So that's how F2 exists and H2 exists. I hope you have understood single covalent bond, and I am sure you have understood why there is mutual sharing of electrons between these atoms. So let's proceed with the next type of covalent bond. So when we talk about the next type, we have double covalent bond. Double covalent bond. Double means 2, yes. So is there any atom which needs 2 electrons? Think about that. Yes, oxygen. Think about oxygen. Oxygen has atomic number 8. So the configuration in second shell is 2, 6. Now it has 6 valence electrons. How many electrons it needs? It needs 2 more electrons. So how O2 gas exists? So let's show the bondings between OO molecule, oxygen atoms. So oxygen has 6 valence electrons. Let's show the electron dot structure. This is how we draw, right? And another oxygen has same 6 electrons in the valence shell. How many electrons each oxygen needs? 2 more. So it means it will share these 2 electrons with the oxygen, and again this oxygen will be stabilized by taking these or sharing these electrons, right? So they both have achieved stable noble gas configuration. But the question arises, how many bonds are formed now? As you can see, there are 2 bonds formed because there are 2 pair of electrons who are sharing the electrons with each other, right? The mutual sharing takes place between 2 pair of electrons. So there is O double bond O formed, right? So can we write the definition now? Yes, let's do that. Double covalent bond is the type of covalent bond in which sharing of 2 pairs of electrons take place, right? 2 electron pairs are being shared. There is a mutual sharing taking place between 2 oxygen atoms in order to become stable. Now, let's proceed with the next example. So now we are talking about the last one, which is triple covalent bond. Triple means 3. So is there any atom which needs 3 electrons? Think about it. Think in 1 to 10 elements. Nitrogen is the answer. Yes, nitrogen has atomic number 7. So the configuration in Kl shell is 2, 5. How this can be converted to 8? By taking 3 more electrons. So nitrogen needs 3 more electrons. So the number of electrons each atom requires, we will show all those 3 electrons together. Let's write the electron dot structure to understand. So how is nitrogen gas exist? This N2 molecule, how does it exist? Let's understand the bondings in the nitrogen atoms. So we have nitrogen. Each nitrogen has 5 electrons. So let's show the valence electrons. This is what I just said, that in order to share 3 electrons, you have to show all 3 electrons together at one side. Why? Let's see. Then we have another nitrogen atom, and again it has 5 electrons. So let's show the 5 electrons. Now, how many electrons this nitrogen needs? The first one. It needs 3 more, right? So that's why we are showing 3 electrons in front of each other, because we need to share these 3 electrons with the other 3 electrons. Is there a complete octet? Yes. See, count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Yes, nitrogen is happy now. And what about the second one? The second nitrogen also is able to share electrons. So, what is the type of bond? How many bonds are formed? There are 3 bonds formed between 2 nitrogen atoms. So, that's why we call it triple covalent bond. Are we ready to write the definition? Yes. So, what is the definition, children? Triple covalent bond is the type of covalent bond which is formed by sharing of 3 pairs of electrons. Are there 3 pairs? Should you count those 3 electrons? Yes, 3 pairs are. This is first pair, this is second pair, this is third pair. How we have decided that nitrogen should form 3 pairs of electron? Because it needs 3 electrons to complete its octet. It has 5 electrons, we need 3 more. So that's how we can conclude that nitrogen needs 3 electrons. So it should make triple covalent bond. Oxygen required 2 electrons, so it made double covalent bond. Hydrogen and fluorine, they need 1 electron only, so that's why they made single covalent bond. So the number of electrons they need is equal to the number of covalent bonds they will make. And what about carbon? Carbon needs 4 more electrons, right? So that's why carbon will make 4 bonds. So let's see more examples of electron dot structures where we have ammonia and methane. So what is the formula for ammonia, children? Ammonia is NH3. In order to show the covalent bond formation, you must write the valence electrons of each atom first. So we have nitrogen here. It has configuration 2, 5, right? And hydrogen has configuration 1. So as we can clearly see, nitrogen needs 3 more electrons. And there are 3 hydrogens for that, isn't so? And what about hydrogen? Hydrogen needs 1 electron each. So let's draw the electron dot structure of nitrogen first. How many valence electrons will you show? 5. Yes. So let's show 5 electrons. This is how I am showing. Why? Because I want to share with 3 hydrogens, right? I want to share the electrons with 3 hydrogens. As the formula says, NH3, there are 3 hydrogens. So 1 electron of hydrogen will be shared here, another electron will be shared here, and third one will be shared here. See, is hydrogen stable now? Let's think about that. Let's make circles or ovals. So here, see, this hydrogen is stable. It has got 2 electrons now. Yes, one which it already has, another from nitrogen. Similarly here, this hydrogen is stable because 1 electron it already had, which is shown by cross, and another it has got from nitrogen by sharing. Similarly, this hydrogen is also stable, right? What about nitrogen? Nitrogen had 5 electrons already, and how many it needs? 3 more. And is it able to achieve all the 3 electrons? Yes. See, let me draw the circle here. See here, nitrogen had 5 electrons, 1, 2, 3, it has got 3 more, so 5 plus 3, 8. The octet of nitrogen is complete by sharing of electrons, right? Now, it is very important and interesting to know here that it is not at all necessary that the atom will share all its electrons. Look at the nitrogen here. Is nitrogen sharing all its valence electrons? No. It depends on how many electrons it actually needs. What is the valency of that atom? For example, the valency of nitrogen is 3. It needs 3 more electrons. So, the sharing has happened with 3 electrons only, and the 2 electrons are not participating in the bond formation, right? So, keep it in mind that it is not necessary that all the electrons which are there in valence shell, they will not participate in making bond. It will depend upon the valency, the number of electrons that atom needs. That will decide how many electrons are actually participating in making bond. Yes. Now, let's talk about methane. Children, methane, the formula is CH4. So, we are talking about carbon now? Yes. So, what is the configuration of carbon? It is 2, 4. See, it has 4 valence electrons. So, do you think all the electrons will participate in making bond? Yes. Why? Because carbon needs 4 more electrons. So, it should share 4 electrons in order to get 4 more, right? Now, what about hydrogen? Hydrogen has 1 electron each. So, there will be mutual sharing of electron. Let's draw the electron dot structure. So, we have carbon here having 4 electrons. Why I am drawing them separately? Because I want to show the bond between 4 more hydrogen atoms. Because it is CH4. Methane gas is CH4. 4 H atoms are attached with carbon. So, to place 4 hydrogen atoms, I should show 4 electrons separately. So, let's put 1 hydrogen here with its electron, another hydrogen here with its electron. So, you can show dot or cross 1 electron with hydrogen here. Now, let's draw the circles or ovals in order to show the complete octet or duplets. So, here look for this left hand side of the hydrogen. This left hydrogen has complete duplet. How? It had 1 electron already and it has got 1 electron from carbon. This hydrogen has got complete duplet. It has 1 electron already and 1 from the carbon. This hydrogen has also got complete duplet. 1 it had already and 1 electron it has got from carbon, and similarly this hydrogen has completed the duplet. Now, what about carbon? Carbon has to complete the octet, not the duplet, right? I am sure that you are already aware what is duplet and octet. Duplet means completing the 2 electrons. As we know that in the first shell we need only 2 electrons, and completing the octet means that there must be 8 electrons in the last shell. So, what about carbon? Carbon needs 8 electrons. It has already 4 electrons here. It needs 4 more. Let's see. So, 4 electrons are already there with the carbon, and see there are 4 hydrogens which are sharing their 1 electron each. So, this is how we should draw the circle here. So, let's count. So, 4 electrons from the carbon, 1, 2, 3, 4, 4 electrons from all the hydrogens, 4 plus 4, 8 electrons are completed by mutually sharing of electrons, and I hope you have understood the concept. Thank you.